De Dutch Cloud Native Days zijn terug en groter dan ooit. Sluit je op 3 juli 2025 aan bij de Dutch Cloud Native Days in de Jaarbeurs Utrecht. Of je nu diep in Kubernetes zit, bouwt met open source, cloudplatformen op schaal beheert of gewoon nieuwsgierig bent naar de toekomst van AI, dit is jouw event. Blijf op de hoogte via dutchcloudnativeday.nl. En voor vaste luisteraars hebben wij extra korting. Gebruik actiecode Community30, dat is Community30, bij het kopen van je ticket en krijg extra korting. Zet dus 3 juli 2025 in je agenda en dan zien we je daar. Welkom bij een nieuwe aflevering van de Nederlandse Kubernetes podcast. De podcast over Kubernetes voor iedereen. Ik ben Ronald Kers en ik zit, zoals altijd, met...
Jan Stomphorst.
Hallo Jan Stomphorst.
Hallo Ronald.
Hoe is het?
Nou, vermoeiend.
Vermoeiend?
Ja, maar wel heel
ik krijg toch hier energie van, joh.
Oh,
dat is
veel energie.
Blijf maar gaan.
Ja, blijf maar gaan. Dus,
eerste dag KubeCon, bijna ten einde. Maar
ja.
wel een top interview weer, denk ik.
ja, maar het is nog de pre-KubeCon, hè? KubeCon is nog niet begonnen.
Voor ons is KubeCon al begonnen.
Ah ja, zeker.
Dus, without further ado, I would like to introduce our guest. That is Holly Cummins.
Hello.
Welcome, Holly.
Thank you.
And you are a senior principal software engineer at Red Hat.
That's right, yeah.
Can you tell our listeners something about yourself? How did you get started in the IT?
My background is actually in physics. I used to do quantum computation, and then I realized that every time I had a problem to solve, I would try and solve it with a computer, no matter what the problem was. And I was always sort of trying to sneak programming in. And then I realized, actually, instead of trying to sneak programming in, I could get paid to do programming. How good is this? And many years later, I'm still getting paid to do programming, which is awesome.
Nice. And what got you? That's how you get started. Was it like an interest from a young age already?
Yeah. So I was always sort of interested in it, and then I just, particularly, I did a PhD in quantum computation, and this is sort of going into the weeds of quantum computation a bit, but you can visualize a quantum gate as a rotation on a sphere. I can see two glazed eyes going.
No. Now we're getting interesting in the. No. We're going to sit up straight because we're going to listen.
We've gone so far from Kubernetes, although it does relate to Kubernetes a bit. But you can visualize a quantum gate instead of being sort of a flip of a bit. It's a rotation on a sphere. And if you do a complex gate, then pretty rapidly your head starts to spin and you're like, wait a minute, where am I on the sphere? So I wanted to visualize it. So I was visualizing these rotations on a sphere. But I knew that maybe I had a problem when I visualized the rotations on the sphere. And then I thought, well, I could make the sphere shaded and that will be nicer. And then I thought, wouldn't it be nice if the path taken along the sphere had a bit of a shape? So it had a bit of a sort of a hump to it and I could ray trace the curve on the path. And at this point, we were so far away from the science and we were so far away from the physics and the quantum computation and everything other than let me just program.
Yeah, it almost felt like a graphic designer at that point, right?
Yeah.
Cool. You have a talk here at KubeCon, zombie hunting for Kubernetes users. Can you tell us a little bit of what's the talk about?
Yeah, so zombie hunting is sort of or zombies in particular. I think they're sometimes the fun side of the climate catastrophe. They're a problem that we all create everywhere. And when we realize we've done it, it's so ridiculous that we kind of have to laugh at ourselves. So there's some sort of amazing statistics about how many computers in the world are doing nothing useful. And when I say nothing useful, I don't mean that these computers are doing cat pictures. These are computers that they haven't done any useful work for 6 months. No data's gone in, no data's gone out. There's no reason for that computer to be chewing up power, but it's still there in the data center chewing up power. And it's quite difficult to get reliable measurements of zombies because by definition, these are computers that we've forgotten about. These are computers that we're not using that they've somewhere in the institutional memory, they got lost.
But nobody dares to touch them.
Well, exactly. Yeah.
With a zombie, actually.
Yeah. I mean, zombies are scary. But the best estimate that we have says that a quarter of computers in data centers are these zombies that are doing nothing. And then there's a further third or so where they've got less than 5% utilization. So you have a whole system occupying all of that memory, occupying all of that CPU, and doing something that, 5% of the time it's doing work. But the rest of the time, you could combine it with other workloads. And I think you just sort of hit on why does this happen, which is often we don't know these systems are there and we have other things to do than to find them. Sometimes we know they're there, but it's scary to turn off a computer, right? You don't get in trouble with your boss for leaving the computer running, but you potentially get into a lot of trouble with your boss if you turn off the computer that you thought was useless.
Exactly.
And it turned out to be useful. I heard a story once. It was a large IT outsourcing organization, and they were doing some tidy up in their sort of, inside their firewall. And they found this system that didn't seem to be doing anything. And so they turned it off. And about half an hour later, they got a phone call from the CTO of their largest client saying, why has the backbone of our network just disappeared? And
Wow.
because, the computer, it had been, misfiled. It was sort of in the wrong part of the network. It looked like it wasn't doing anything. And it turns out it was doing something quite important.
Yeah. Maybe some old system engineer that worked there in the beginning and he left and nobody, it's not documented somehow, and then.
Yeah. I mean, you just get so many of these stories. There's another one, this is just sort of an anecdotal one from someone, and he'd gone for a job interview, and there was this, exactly as you say, this like ancient computer that was in the corner. And he said, oh, what does that computer do? And they said, oh, well, it's connected to this other computer. And they pointed to the second ancient computer. And he said, okay, but what do the pair of them do? And they said, well, we don't know. Nobody's known for 20 years, but we're too scared to turn it off.
Yeah. So how do you hunt them?
Well, yeah, it's sort of, I think, this is where the fun part sort of starts to come in, because you imagine that what you do is, you go into the data center with a flamethrower.
Burn it down, baby.
Yeah. And, to some extent, it sounds very irresponsible to go into the data center with a flamethrower, and you can't do that in a regulated industry. But it's not a completely ridiculous approach. If you have the organizational maturity to do chaos testing, then you can rebrand your chaos testing as zombie testing, and you can start turning these things.
That's one way to look at it. Yeah.
Yeah. I sort of, I sometimes think, that we've got all of the chaos, the sort of the chaos monkeys, and you can add a new monkey and you just call it eco monkey, and you turn off the worklist. So that is a very aggressive approach to do it. You have to have a lot of sort of institutional trust to be able to do that. There's other things that we can be doing though, and the nice thing is a lot of them are actually ridiculously simple. One of the simplest things that I really like is because quite often these systems they end up being provisioned for a good reason, and then that reason goes away and we forget to deprovision them. And so what you can do is, with your automated provisioning system, your nice self-service automated provisioning system, you just put in a lease on it so that instead of staying alive by default forever, it shuts itself off after 2 weeks. So it's sort of like the Blade Runner model for computers, right? That, they have an expiry date. And again, you probably don't want to do that on your production infrastructure, but most of our infrastructure, is just things like sandboxes, it's things like exploration, it's things like prototyping. And so if you have that kind of expiry model, if people are using it, they have a very strong incentive to renew it. If they're not using it, or if they've temporarily stopped using it, they can just let the lease expire. So that's quite nice. The other thing that you can do, if, again, sort of some workloads are temporary, and so then that lease model works really well for that. Mm-hmm. Other workloads, you probably do want to keep them running permanently because they're your production workload, but often you only need them at certain times. So, for example, batch workloads. I was visiting a business a while ago, and they had this batch workload that ran at the weekends, and they keep the computers up all week, and it, it's wasteful. So you can just put in place some really simple scripting. You can do your shell script or your cron job, and you can save potentially 30% of your cloud costs just with that little bit of scripting. And we're starting to see some tools in this area now. So, obviously you can do it the old-fashioned way and just do a shell script. But AXA France have an open source project called Dailyclean, and it's particularly targeted towards Kubernetes. So the idea is, if as a Kubernetes user, I don't necessarily want to spend all of my time trying to figure out the cron syntax, because nobody can figure out the cron syntax, and it takes you about 10 attempts. And if it's a sort of a important workload, maybe you don't want to be doing that process of experimentation with the cron syntax. So it's got a GUI on it. So again, it just reduces a little bit of friction to turning that workload off. So you have a pod in your cluster, and that pod is serving a GUI, and you can just go into the GUI and you can say, this one, I need it to stay up between 9 and 5. This one, I need it, I need it most of the time. And so it just gives you that sort of graphical control. There's a nice side thing with Dailyclean, which is one of the natural questions when you have this kind of automation is, well, wait a minute, what if the cure is worse than the disease? What if we actually end up using more resources for our automation than we saved?
Often is that the point.
Yeah. And my day job is that I'm a developer for Quarkus. And Quarkus can run, it's Java applications, but it can run as a natively compiled binary with a tiny memory footprint, and tiny startup time and all of that. And so Dailyclean in the pod that's running the scheduling, it's using Quarkus so that it's got this super light footprint. There's other products as well. So there's a new one which I haven't tried personally. It's a commercial product, but it's called Turn It Off. And so it's sort of this supporting this use case of, I just don't need these things to be running all of the time.
Yeah, I was also thinking of like observability tooling and stuff, and tools that scan your network and can, like a KubeCost, you can see the cost and scale down the resources. What if you just squeeze the resources of those machines? So they kept running, but you'll find out eventually if they are but you're reducing the cost gradually, or is that something weird I'm saying here?
No, you can do that. But what if you have an application that has spiky load? So sometimes you don't know when has a spike in the load, but you don't. Okay, and that this happens often. You don't have the development workload to do multiple pods or do something auto scaling. So I've got one customer that is saying, I over provision my pods a lot with to
handle the load,
handle the spiky load.
Yeah.
And how do you solve that?
That's a really good point. And because nobody wants to be the person who under provisioned and
because then your application fails or dies or so something happens with your application. Killer. Yeah, the Ohm killer. The dreaded Ohm killer. and people don't want that. And
Absolutely.
The cheapest way to solve that is add memory.
Yeah, and so I think you're completely right. And that spiky load scenario is definitely the hardest to solve, because some of the other ones it's just so obvious.
Yeah, it's easy. Yeah, batch workloads and scheduling. It's just simple thinking, and it's easy to solve.
But it's mostly those kind of things that happen the most. Also,
no, I don't think so. Yeah, but
certainly it is common.
It's one of the things, but the spiky load is. Yeah.
And so one thing you can do is, so auto scaling can help a little bit, but there's two problems with auto scaling. One is, just like the person doesn't want to be the person that under provisioned and caused the outage, no one wants to write the auto scaler that's too aggressive in scaling down and causes an outage. So they always have a bias to scale up eagerly and to be pretty reluctant to scale down. And that's sort of a because of what we're optimizing.
Yeah, I had also a case that a customer had an aggressive auto scaling, and they were scaling the whole time. So they didn't serve anything. They were scaling up, and then the application said, "Oh, I don't have anything to do," because everybody was gone. They did refresh, and the application scaled down, and then everybody was refreshing, and it scaled up again. And then everybody was gone. So it was a vicious circle of auto-scaling.
Yeah. So one thing that can help with that a little bit, not completely, you still have to tune it, is having different characteristics of application that are serving the same workload. So, for example, this actually comes back to Quarkus again, although that's a Java-specific one. You might want to have most of your workloads just running, as that's your baseline. You tell your autoscaler, please don't get rid of these, just keep them running. But then you remember how we used to talk about cloud bursting a lot, that if you get the spike, then all of a sudden you pull in the extra resources and you need to be able to do it quickly. So you can do the same thing with your workloads, that you have your base workload that maybe is a bit slow to spin up, but it's got high throughput and it's solid. And then you have nodes that are maybe compiled to a native binary or in some other way architected to be able to spin up really quickly. And so then you can have that hybrid workload to be able to...
Kost het beheer van Kubernetes je veel tijd en expertise? Maak kennis met ACC ICT. Zij ontzorgen je volledig met managed Kubernetes diensten op elke cloud. Gecertificeerde specialisten zorgen voor compleet beheer, 24/7 support en optimale beveiliging. Jij kunt je focussen op je core business, terwijl je Kubernetes-omgeving in betrouwbare handen is. Manage Kubernetes van ACC ICT. Jouw zorg, onze expertise. Bezoek accict.com.
And do you do vertical scaling instead of horizontal scaling?
I mean, this is a question I ask myself actually, is which is best, and I don't know.
Because some applications and some developers are not ready yet to do an horizontal scaling. And if you have a timed application, like we've got a customer that deals with public transit, so every message that comes in is timed. And so if he has 2 containers running, he doesn't know when the first container is doing the thing and the other container doing the other thing, and the things get mixed up. So he needs a perfect timeline.
Yeah.
And that only can happen properly with one process. But he also has spiky load.
Yeah.
I've got them in my
Yeah,
pocket here.
you're getting the anomalies.
But I think, leaving aside all of the horrible edge cases.
No, that's not edge cases.
Well, okay, but they are horrible.
Yeah.
I think what's surprising about the zombies is the fact that quite often it is the stupidly easy cases, and it is the things that we forgot, and it is the things that we over-provisioned even though there's no spiky workload and we were just being cautious. Or often there's this problem with institutional memory where a system was supporting a process that was useful, and then we switched to a new process.
Yeah.
And then, but once nobody remembered to decommission the old one, because that's kind of boring work, and we're not really measured on it. We're measured on how are we making the new one a success, not did we get rid of the old one.
Do you think AI can do something in this field also?
I think so, yeah. So it's not the sort of the latest batch of generative AI, but AI ops tooling has been helping in this area for a while, actually, with things like again, just sort of looking at your estate and getting that utilization optimized. So again, this is just one number that I heard from one story. But the Turbonomic product, when IBM bought the Turbonomic product, they said, well, we should eat our own dog food. Let's roll it out in our data center. And they saw apparently a 21% cost saving just from doing nothing, basically, except rolling out the AI Ops product. And I think we can see, there's a range. I mean, it's a huge growth area, isn't it? This sort of optimization, because we have all these things, we don't really know what they are. Something like tagging is not scalable as a way of managing these things. So we do need that. Because there's some things as well, like some of these things that I'm not aware of a product that does this, but it may be that there are some, but it's so obvious that we should be doing this, is of just, traffic monitoring and using that to guide our long-term utilization decisions.
Yeah, that should be a way to do it. To find out if something happened, but yeah.
No, that's... you said Quarkus is for Java.
Yes.
And we had a podcast about Java memory. Java has
it comes.
has a heap.
You said Java, and I was okay. Now we can wait for the heap one.
No, but it's a perfect case, because you have to provision your heap in forehand.
Yeah.
And how do you solve that?
So this is interesting. Java is it's a language with some history. And what Java was originally optimized for was environments where you didn't talk to your ops person. You did everything you could to avoid talking to your ops person. You did everything you could to avoid deploying. But of course, the world didn't stop. So you still had to patch these systems, but you wanted to patch them without doing major redeployments, because we didn't have DevOps and we didn't have pipelines, and it was the dark ages. And so the way Java was really engineered was to allow you to change the engine while the plane was flying. So the internals were hugely dynamic, and you could swap out a library and swap in another library, and then you could swap out and you could do this, repeatedly and just never take the application down. That very clever engineering
Sounds awesome.
Makes no sense in a world with containers.
No.
Because if you're SSHing into your Java application to swap out a library, you have missed the last 10 years of development, right? We have pipelines, we have containers.
Right.
You do not patch your runtimes, you just run the pipeline.
The new one.
And yeah. And so what the Quarkus team did is they looked at all of this dynamism that was sort of baked into Java and baked into all of the libraries. And they went, this dynamism has an enormous cost. We're paying a tax for the dynamism. So it has a cost in terms of memory footprint, and it has a cost in terms of startup time, and it has a cost in terms of throughput. All of those are bad. And we're not even using the dynamism because we have containers. This is stupid. So what they did was they re-architected a bunch of the popular libraries like Hibernate to say, what if instead of having all that dynamism that we're not using, we just kind of baked in those decisions up front at build time, and then when you push your application out to the container runtime, it's got half the memory footprint. It starts up in, a quarter of the time. And it's still just a normal Java application. So it's really able to solve the memory problem of Java and make it much, much more suitable to a cloud environment.
It makes it smaller, but it doesn't solve the heap. Or
it does make the heap. Yeah,
it makes it smaller.
Yeah, it makes the heap maybe half, maybe a third. That depending on the workload. So, so you get an.
That's awesome.
Yeah, and then you can go further as well, that's just stripping out the reflection, but still having it as a Java application. But then you can take advantage of GraalVM, and Quarkus makes it really easy to take advantage of GraalVM. And then you can go down to a natively compiled binary. And there your heap is maybe a tenth of what it would have been for, an old-fashioned Java application. So it's starting to look...
It's also a huge cost saving.
Yeah, exactly. So we find that when people switch to Quarkus, their costs... Again, they sort of shave 2/3 off their costs, and their applications actually look exactly as they did before. The code is the same, but the runtime costs and the resource usage are so much smaller.
Oh, Let's switch then.
Let's switch then. What's the catch?
I mean, often there's an inertia, right? There's change. Change is hard. And usually what we find is a lot of IT organizations will say, well, if it's not broke, I'm not fixing it.
Exactly.
And then they get their cloud bill and they go, you know what? This is broken.
This is very broken.
Let's fix
Yeah.
this.
When money comes into play, it's always people start thinking.
Yeah, we heard some stories that with the spike in electricity prices a couple of years ago, all of a sudden some departments that had switched to Quarkus were sort of going, yeah, this is fine, we don't have a problem, and the other departments were going, we're really suffering because of this spike in electricity.
Yeah, we had a guest on our podcast from Ascent, one of the largest energy providers in the Netherlands or Europe. Ascent is Europe, right? And he said when the gas prices and energy prices went up significantly, people were updating their app, refreshing the app to check the prices every time, and that took down their whole environment for a week. They had to shut down every communication within the app to their network to provision their own infrastructure in a way they could handle the load of every customer updating their app.
It's not over-provisioned.
Not over-provisioned.
But what do I have to do to use Quarkus?
So if you have a Spring Java application, you've got two options. To start off with, if you've got like a microprofile Java application, almost certainly you're already using the right libraries. It's just a question of taking the code and plunking it into you with the Quarkus dependencies. If you've got a Spring Java application, then we have a compatibility layer. So you can just, in your pom.xml, you can swap out the Spring dependencies for the Quarkus equivalents. That doesn't give you perfect compatibility, of course, because otherwise then it would just be Spring. But we cover the most common, I think, something like 90% of the most common. So that's certainly a good thing to try. Or there's migration tooling available as well. So things like Open Rewrite have recipes that you can use to migrate.
Okay, awesome. And because you can, Java nowadays has an option to be container aware.
We're getting there. Yeah.
No. But it's clunky and not. Is Quarkus also doing something with that?
Absolutely, yeah. So one of the things that we sort of describe Quarkus as is cloud native Java and Kubernetes native Java. So it's really intended to be a first class citizen in containers, and it's intended that when you build your Quarkus application, for example, you're most likely going to want a container image. So that support for baking in a container image that's maybe, going to be a bit smarter than just taking your binary and, putting it as the last layer in a Docker file. That's all baked into there. And there's sort of various facilities as well. So for example, there's a remote development option so that you can have your application deployed into a cluster, but you're working on it locally, and then the code changes are pushed up as live coding automatically to the cluster.
Again, that's cool.
Yeah, and not for production, obviously. But.
And it's changing the code then in the container. You're okay. Yeah, that's not for production.
Yeah,
that's stupid. But if you're developing, it's going to be faster then.
Yeah, absolutely. And one of the other things that we've done, we often say with Quarkus, people sort of come for the performance and they come for those footprint savings, and then they stay for the developer experience.
Okay.
Because we're doing so much at build time, you might say, well, then this is terrible for the developer experience. You've just shoved all of the pain from production, which I don't care about, to development, which I care about a lot. But it's the opposite. Because we have so much control over what's going on, it means that we can support live coding. So hot reload, and this is something, for example, that JS developers have been used to for a while, and Java was sort of stuck there going, oh, it's not that bad to just recompile every time. No, it is that bad to recompile every time. So Quarkus has a dev mode where you, again, if you're not trying to do your local development in a Remoco model with remote Kubernetes, then you can just do Quarkus dev, and then your changes are just visible live instantly.
Awesome.
Yeah.
So, zombie shooting with Quarkus. So, how do you see the future then with Quarkus and zombie shooting and Kubernetes and?
I think the answer is AI, of course.
Oh yeah.
And we're done.
and we're done.
But I can actually answer. There's sort of a slightly different answer for both of that, for both of those sub questions, actually, both relating to AI. So with Java, for example, Java has traditionally not been at the forefront of what had been going on with model development and that kind of thing. No. But now that we're going to the next stage, what we need to be doing is integrating these models into our applications. We need to be infusing AI. We need to be as well taking these models and running them in production, but with the enterprise qualities of service that we want, like failover and resiliency and security. And this is a problem that Java has solved. And so we can take some of that integration expertise that the Java ecosystem has and apply it to AI. So with Quarkus, for example, we're really excited about LangChain4j, and we have this really, really nice LangChain4j integration. So you can just, with one or two annotations, have your Java application talking to OpenAI or whatever. Then for the Kubernetes ecosystem, I think the answer is also AI. But the challenge.
Mic drop again.
Yeah.
But the challenge is also AI, right? Like Kubernetes and cloud native has really traditionally been everything is stateless, and the way we get our scalability, the way we get our efficiency, and the way we get just that cloud nativeness is by being stateless.
Yeah.
Stateless and AI are kind of
contradictory, right?
Yeah, exactly.
Yeah, but a lot of workloads are not stateless, and a lot of developers, it's a lot of work to build stateless applications, and we don't have the money for that.
Yeah, so I think this is something that the ecosystem has to then step in for and say, we need to make Kubernetes have the right capabilities built in at the ecosystem layer to support the things that developers are going to want to be doing with these really data-intensive workloads.
Yeah.
See you thinking?
Yeah, I'm thinking all. No, it's awesome. That's awesome. Bright future, I think.
I think so.
Yeah,
I think it's exactly the right combination of lots of good things coming down the pipeline and lots of interesting problems, which us as developers can solve, which is why we got into this.
Yeah, that's become a developer, right?
Yeah.
Solving problems.
Yeah.
Holly, thank you so much for joining us in our podcast. And we'd love to do a follow-up on this and maybe shoot some zombies in the future.
With Quarkus.
Yeah, we can gamify it.
Yeah, gamify it. Yeah, exactly. Thank you very much.
Thank
Okay,
you.
bye.
Deze podcast is een initiatief van ACC ICT en wij zijn te beluisteren op onze website k8spodcast.nl, via Spotify, Apple en alle andere favoriete podcastproviders. Aflevering 100 van de Nederlandse Kubernetes podcast komt eraan en dat vieren we groots. Op 26 juni gaan we de ultieme podcastmarathon doen. Zonder eten, voor het goede doel, de voedselbank. Volg ons via accict.com/live. We hebben toffe gasten, scherpe inhoud en impact. Kijk mee, doneer mee en help ons zoveel mogelijk voedselpakketten in te zamelen. accict.com/live, 26 juni. Zet het in je agenda.